today's opening ceremony, I would like to introduce our guest speaker. Before I hand over the mic to him, I would like to say a couple of words for him. So he is a Canadian author, artificial intelligence, and ML systems architect, TED keynote speaker, media personality, Google developer expert for machine learning, and developer advocate for IBM. Not only that, but he has addressed over 200,000 executives, developers, and leaders worldwide at conferences, universities, financial institutions, and international companies. The United Nations Linux Foundation, Apple, SAP, IBM, KPMG, Microsoft, and Walmart are a few of the organizations he has keynoted for. Whew. And here's the most exciting part. He's also a teenager. Let's welcome Tanmay Bakshi.
Hi, everybody. Hello, Lovedy. Thanks for inviting me. Really quickly, I will need to share my screen because I do have a couple of things that I want to show you all. Give me just a moment. I don't seem to have permission to do that. Could you maybe, let's see. It says host disabled attendee.
I will stop. Okay, perfect. Ashay, you got that?
Hi, can you hear me now?
Yeah.
Perfect, but I can't seem to share my screen.
Okay.
Host has disabled attendee screen sharing. If possible, it would be great if I could show a couple of slides because there's okay, there we go. Can you see my screen now?
Yep.
Perfect. Thank you very much. So thank you, Lovedy, for having me be a part of the session. I'm really excited. Really quickly to begin today, as you know, my name is Tanmay Bakshi, and my passion is to explore technology. Specifically, I love taking next generation technologies like machine learning or artificial intelligence, whatever you may call it. We'll get into that in a moment, and really applying it to solve problems in a variety of different fields. So healthcare and education are some of the fields that I'm most passionate about. And then from there, not only applying that technology, but also making it accessible for more people to use and more people to actually implement in their applications as well is something that I'm really passionate about. And so before we get into that tech, I do want to start off by saying a huge thank you to the Teens Take on COVID team for putting this together. I mean, Lovedy, Ashay, and Soham have put in a lot of work to make this happen, especially during a time like this one. So thank you to them for that. I am really excited to be a part of the hackathon. And really the reason that I'm so excited about this is because if you think about it, developers are problem solvers, right? I mean, that's what we do. We take problems, the world's problems, and we solve them with the power of the code that we write or the technology that we create. And for the past couple of months, we've been facing a next generation problem, right? The kind of problem that is at a scale that we've never seen before. And it only makes sense that obviously we would use next generation technology to solve that problem, and that we'd want to tap into the next generation of developers to help us solve it too. And so what I really want to say is that as you're hacking, as you're participating in this hackathon, make sure that you remember that you're not just developers, you're not just writing code, you are actively working towards solving the world's problems and saving lives and making the world a better place. And so that's exactly why I'm so excited about this initiative. And what's amazing is that you can have fun as you solve the world's problems too, because obviously when you're passionate about something and when you love doing something like code, then it's fun for you to do. Like, for example, me, I absolutely enjoy working with technology. It's what I've been doing for many years now, and it's just something that I really enjoy, which is why I'm so passionate about working with technology. As a matter of fact, something I want to do before we talk about this like next generation technology and what you can do through this hackathon is maybe give you a bit of background as to why technology is so exciting for me and why technology is so fun. And really the reason for that is because, I mean, initially when I got into the world of technology was when I was around 5 years old. And so this was back, 11 years ago. Back then, obviously, the computer was basically just something I would play with, right? I mean, it was just a toy, essentially. But the thing is, the reason technology fascinated me so much was because you could interact with it in infinitely more ways than you could interact with anything else. There was just so much more that it could do. to seemed limitless, right? And that's what really sort of ignited my curiosity for the field of technology. And what was great is my dad saw that curiosity that I had and introduced me to the world of programming and the world of technology back when I was 5 through simple languages. But the thing is, my curiosity obviously just sort of kept growing from there. And when I was 9 years old, I had my very first iOS application called T-Tables accepted into the Apple App Store as I started to scale up and started to use different resources like the internet and different books to learn even more languages and frameworks. And when I made this application, I really realized something, and that was that sure, I could create applications that help people like I had done and uploaded to the App Store, but at the same time, I could also create content that enables people to create their own apps. And so that's why I started my YouTube channel called Tanmay Teaches, where I would upload tutorials ranging in topic from iOS app development and programming to math and science. And from there, that YouTube channel made me realize that there actually is a lack of resources for the beginners that want to get into the world of technology and sort of learn about this world of programming and coding, which is why I initiated my goal to reach out to at least 100,000 aspiring coders to really help them innovate along their journey of learning to code. And in fact, I am glad to say that so far I'm around 17,000 people there, and I'm working towards this goal through really as many media as possible. I mean, I mentioned my YouTube channel. There's the talks and the workshops and the keynotes that I have at schools, universities, and conferences, really making it so that when people have ideas, they actually have the capability to implement technology to make an impact. And I'm also glad to say that just last year, in order to scale up this initiative, I also had 3 of my books published on technology. So they're Hello Swift, Cognitive Computing with IBM Watson, and Tanmay Teaches Julia. And so really I'm working towards this through as many media as possible, enabling people to work with technology and next generation technology. So, I mean, we've already sort of skipped ahead to the part where I'm talking about next generation technology. So let's sort of step back for a moment so you can figure out why I'm so passionate about this machine learning AI stuff first. And really the reason for that is because back when I was like 11 years old, of course I was working with technology back then, but I started to find it not nearly as fascinating as it was a little while ago. And mainly the reason for that, for me at least, was because I felt like technology was pretty rigid in a way, where when you code something in or when you implement something, it starts becoming obsolete immediately. It doesn't adapt, right? It doesn't change itself based off of interactions with users, or it doesn't adapt to new data that's generated. And that felt like a really big limitation to me. But then really that entire perception of mine when it came to the world of technology changed one day when I had stumbled upon IBM Watson and how it won the Jeopardy game show against the 2 best human competitors on that game show back in 2011. Now, I mean, I'm sure everybody here has, of course, heard of IBM Watson and most likely heard of Watson playing and winning Jeopardy. It's one of the most famous examples of this early, next generation machine learning technology. And what's so fascinating about Watson playing Jeopardy is that it's understanding natural language information. I mean, you take for granted just how complex that is. A single sentence can have hundreds, if not thousands, of different meanings or different interpretations, syntactically and semantically. There's so many ways to perceive natural language data. I mean, for example, one of the most popular actually examples of this sort of ambiguity in natural language is the sentence, "I shot an elephant in my pajamas." I mean, that seems like a simple sentence, but there are many different ways you can interpret that. You could say, you're taking a picture of an elephant while you were wearing your pajamas, or you could, with the exact same sentence, you could say the elephant was wearing your pajamas and you were, shooting the elephant, hunting the elephant. As a matter of fact, I was once doing this talk at a school, and I asked the audience if they had any other interpretations, and it was pretty funny because another valid interpretation of the sentence would be that the elephant was physically inside of your pajamas, right? So it's really ambiguous. And that's just a simple sentence. Jeopardy clues are purposefully complex, containing all sorts of riddles, all sorts of wordplay. And the thing is, you somehow have to deal with that and understand that mathematically through a computer. So when I saw that, obviously, I was immediately intrigued, and I wanted to figure out how that works and how I can do that for myself. And so really, ever since then, I have been hooked to implementing this technology in essentially all of the different applications that I develop or the technology that I implement. And I feel like in order to understand just why machine learning is so impressive and why it's so important, it's sometimes more important to take a step back and really think about humans and what we do and why it's so special. I mean, I've already talked about, for example, we have these special abilities like understanding natural language data that are unique to us. I mean, we have some of the most complex communication abilities of any animal ever. I mean, it's amazing that we can take mental states, we can take imagination, things that haven't really ever concretely happened. We can take an abstract thought and represent it in words and get that across to another human. That is pretty amazing. And the thing is, natural language and other sorts of data, like, for example, visual data, vision and actually seeing different objects in the real world, this is the kind of data that we use as humans in order to interact with the world around us. And this data is incredibly complex to understand. But with the power of machine learning, we can actually start to do that. I mean, like, for example, visual data, incredibly complex. You're taking a look at this eye on screen right now, but the thing is, your mind understands perspective, and it knows that what you're seeing is not a physical human eye that's that big, but it understands that that's just a picture of a human eye really up close, right? It understands that perspective. And with the power of machine learning, we can actually start to understand this visual data through technology and implement applications like, for example, Tesla's self-driving cars, Tesla's autopilot, in order to enable, in this case, a better experience for drivers, a safer experience for drivers. So the developers behind the Tesla autopilot were able to solve that problem. And it doesn't even end there. There's so much more data. For example, auditory data, right? I mean, think about just how complex auditory data is. Like right now, if you were here with me in person, what would be happening is, as I was speaking, I would be vibrating molecules of air, and your ears are picking up on those vibrations and converting them to electrical signals. And you're somehow understanding patterns in electrical signals in order to understand what it is that I'm saying. That's really an incredible capability. And now, with the power of this machine learning technology that we've had only for the past around 5 or 6 years now, we can now understand that data through the power of technology, and this enables applications like, for example, Siri. Right? You can just say, "Hey Siri," and hopefully that doesn't. Oh, that does actually hit my phone. You can say these words, and you can have the technology actually understand what it is that you're saying, and you can have this more interactive user experience. And these are just some examples. There are hundreds of thousands of examples of giving these sorts of abilities to computers with the power of this next generation technology. Because if you think about it, computers are fundamentally limited really to just understanding mathematical data, right? Crunching numbers and running mathematical operations. And we invented technology to do that because that's something that we can do. And that's why technology has been useful to us for so long. But now that we are starting to reach those limits of computing power, that is starting to become a bigger and bigger limitation, right? We want to be able to understand unstructured data, which is the way we interact with the world through our technology. And that is precisely what machine learning technology enables us to do. And before we transition into a question answering session where I would love to answer any questions you may have, there are two more things that I want to say. And that is that, first of all, machine learning technology, or really any technology, you shouldn't treat it as, you shouldn't treat it as a one size fits all solution to every problem. Really, as a developer, what you have to be thinking about is, I've got all these different tools. Machine learning might be one of them. All the other algorithms that you know of, or all the other APIs that you've got, they're just tools in your toolbox. And your goal is to say, how can I use those tools that I've got to solve a larger problem? And I want to give you a great example of what amazing things can happen when you think about solving problems instead of using technology. So think about it problem first or problem backwards, not technology forward. And what you're seeing on screen right now is text that was handwritten. Right? It looks handwritten, at least. Like, it looks like a human could have written this. There's small errors here and there. It's not a constant style. It's not like a font. But you might be surprised to know that this handwriting was actually generated by a neural network. This was generated by a machine learning algorithm, and the original variety of this algorithm was devised by a researcher, Alex Graves, at the University of Toronto. And now here's the special thing about this. When Alex was coming up with this network, obviously he didn't say, "I've got machine learning technology, what can I do with it?" Because that would be an incredibly narrow scope to view. Rather, what he said was, "I want to generate handwriting. How can I do that?" And then by taking a look at all the different, machine learning based tools he has, he was able to come up with this complex architecture of a bunch of different components that are individually very simple and that already exist and are well documented. But then when put together in the way that he put it together was completely novel and opened up this whole new world of research. I mean, you don't really need to know what those components are, but in case you're curious, they're LSTM networks with an attention mechanism that uses a mixture density network that's optimized by gradient descent, right? These are things that have already existed for decades, literally since the 70s or 80s. But now, when he put it together in this way, he was able to generate handwriting, and that's incredible. And so what I want you to do is, through this hackathon, I want you to think, what are some problems that I'm passionate about solving, very specific problems, and how can I break that down in a way that I can solve it with the tools that technology provides me? That's the way that I think you should think about it. And in case you're curious about what kinds of tools you actually have at your disposal, I would recommend going to a website called cognitiveclass.ai. It's a wonderful free learning platform where you can get access to all sorts of courses and learning paths to learn about all sorts of different technologies, all the way from simple Python and Swift coding, all the way to complex machine learning and calculus. And the best part is that in case you're curious about, for example, how to use IBM Cloud or how to use the different IBM Watson services in order to integrate this intelligence into your applications without needing to know how the intelligence actually works, Cognitive Class will tell you exactly that. I've also got a couple of courses on this platform around this world of machine learning, and so feel free to take a look. I'm sure it's going to be incredibly helpful to get you jump-started on working with this technology to implement solutions for this hackathon. Apart from that, you can also feel free to take a look at different resources on my YouTube channel, Tanmay Teaches, or reach out to the mentors on Slack. I'll also be on Slack in case you want to ask me any questions. Feel free to do that, and I would love to answer those. But we also do have a question answering session after this little talk here, so feel free to ask any questions now as well. I would love to answer them. And finally, I absolutely cannot wait to see the problems that you solve with code and the technology that you create. And so now I would love to answer any questions you may have, and then I'll hand it back over to the organizers, maybe Labdi, and then you're going to have a fun time at the hackathon. Thank you.
I'm going to share my screen back.
Please don't be shy. Just say any question you have in the chat.
Sometimes it takes a bit, but I'm sure you'll have some questions. Let's see. There's a chat. Oh, there is one question. I have a quick question. How did you become so proficient at speaking to a large group of people? Really, I mean, it's not really something that I sort of had to. I guess it's just something that I enjoy doing, right? Like, for example, code and technology, it's something that I've always enjoyed and have been passionate about. And similarly, I've always loved being able to take technology and enable people to use it, and enable people to leverage that technology. And so being able to interact with people in these sorts of environments and sort of talk with them and interact with them is really useful in being able to share my knowledge that way. All right, so we see another question. Other than IBM's Watson, what is another one of your favorite examples of artificial intelligence? Let's see. So first of all, I would say it depends. So IBM Watson, in terms of how it played Jeopardy, that's my absolute #1 all-time favorite example of artificial intelligence. From there, I would also say a new grand challenge from IBM Research called Project Debater is a platform that essentially implements computational argumentation. So it's a platform that can automatically debate with humans and engage in complex debate, even modeling human dilemmas in an automated fashion on any topic that you give it. So that's definitely something that I'm interested in. But also, I'm very fascinated by applications like, for example, DeepMind's AlphaZero and MuZero. There's also a new algorithm by Uber Research. I do not remember what the algorithm is called, but it enables the algorithms to learn new Atari games that previously no computer was able to master by exploring with a sort of mathematical curiosity. So these sorts of algorithms really fascinate me because they allow us to see the ways that AI can interact with an environment and learn automatically. Although the reason that Watson and Project Debater are at the forefront, and really I'm fascinated by them, is because they're open domain. Within a game, like for example, what DeepMind does or what Uber Research does, within a game, you have a set number of rules and environments and states, and even if it's slightly stochastic, even if there's some randomness involved, you can still explore the search space. You can still go through all the possible states and figure out ways to play the game. But within an open domain context, like answering Jeopardy clues or debating with a human, there's really no bounds to where it can go. And so there's no way to measure that, hey, I have this score in debating, because that's subjective. You can't really say that. So that's definitely my favorite. Another question from Caitlin, how did you first start learning how to work with AI and machine learning? So initially, the way that I started was actually through using the Watson APIs. And the reason that was really helpful was because in order to use the Watson APIs, you don't really need to know how any of the AI or machine learning works, because you don't need to know what goes on in the back end. All you need to do is implement the REST APIs. You can just call Watson from your code. It's very simple. But at the same time, it gives you a really good sort of mental framework of what machine learning is capable of. And when you understand what it's capable of, then you start to understand how you can use it. And then from there, you can get into even more technical details. And so what I would recommend is, again, using resources like my YouTube channel, Tanmay Teaches, or for example, cognitiveClass.ai to get into these sorts of simple versions of machine learning. And then from there, you can get slowly more and more technical. So for example, from there, maybe you want to take a look at something called a perceptron, which is a basic building block or the basic unit of these larger neural networks. So for example, what you just saw with the handwriting generation from Alex Graves, that network actually has hundreds of thousands of these things called perceptrons that are working together in a specific structure that he put together in order to handwrite. And so if you learn how those individual building blocks work mathematically, then it's pretty easy to scale up. So I would recommend starting off with the simple applications and use cases, like with APIs, and then scaling up from there. All right, let's wait maybe a minute more. Maybe there's some more questions.
Meanwhile we wait, we actually had, the organizer, we had a couple of questions for you. Yeah, so what do you think the future holds for artificial intelligence?
So there are two ways that I could answer that, and there's the technical way, or there's the way that I feel like humanity in general will advance artificial intelligence. And I feel like two things will happen. First of all, from a humanity perspective, we're going to continue to make these like huge predictions of what AI will accomplish in the future, but we're going to start to realize that it's not exactly the kind of technology that we thought it was. Right? It's not truly intelligent technology. It's not as intelligent. Well, it's not intelligent at all, but it's not as capable necessarily as a lot of people thought it would be. And what that's going to do is, as we continue to make those predictions but never really meet them, we're going to start to sort of see this sort of flattening of expectations, and people will start to become a lot more grounded when it comes to expecting the future of technology. We're going to start to take it with a lot more realism. optimism rather than the skepticism that we see it with today. I mean, like, for example, and this is an example that I like to give because it really highlights just the weird way that our mind works when it comes to artificial intelligence. Your Apple Watch, if you have an Apple Watch Series 4 or above, then it has this thing called fall detection, where if you take a fall, it'll detect that and it'll call emergency services. But the thing is, that's powered by machine learning. And essentially it's powered by mathematics. It's the learning algorithm that will actually analyze accelerometer and gyroscope data to detect a fall. But then when you take essentially the same fundamental mathematics and you put it onto, for example, Siri, the personal assistant, or Pepper, the humanoid robot, then suddenly people switch from calling it machine learning to artificial intelligence, even though it's the exact same technology. And the thing that annoys me about that is that we as humans start to ask the wrong questions, or we start to make the wrong decisions, or we start to stifle innovation with unnecessary regulation just because, hey, we thought artificial intelligence was something else, whereas from a true technical angle, it's just calculus, right? So really, I feel like we're going to start to see people becoming a lot more realistic with their expectations, but we're also going to see a huge advent of new algorithms within the field of machine learning that solve, I would say, three major problems. First of all, explainability. So AI algorithms will be more explainable. For example, the handwriting that was generated. Currently, we don't know what kinds of patterns it learned from human handwriting in order to generate that. But being able to have an explainable model to actually analyze, where this knowledge came from is important for more complex use cases like those in healthcare, for example. We're going to start to see more algorithms that aren't as dependent on data, so we can, keep people's privacy intact. And we're also going to see more algorithms that are resistant to bias on certain kinds of data. Bias, not necessarily even in the way that we think of bias, but just generally bias in the sense of, for example, maybe there's more data towards a certain kind of example and less towards a certain kind. So if you're building a machine learning algorithm to predict if a jet engine is going to fail, maybe you have more data for GE engines than Rolls-Royce engines, and suddenly your algorithm is biased towards one brand. Well, it's this kind of bias that we want to mitigate in our machine learning models. So from a societal perspective, we're going to see different sort of expectations from AI, but then we're also going to see those three major problems solved over the next couple of years as well.
All right. So, Ashay, Soham, do you guys have any questions?
Yeah, just like a follow-up question to that. What do you expect, what sort of fields do you think within artificial intelligence will have the largest growth in the next decade or 2 decades?
So I would say the most impact that would be the fields of healthcare and education, which is why I'm so passionate about those two fields. And the reason I say that is because specifically within the field of healthcare, we have a lot of data. Like we have more data than you can possibly really conceptualize in your mind. And the thing is, we have all this data, but we're not really using it, in the sense that we're not able to analyze any of it computationally because it's unstructured. And because of that, all we're doing is we're saying, okay, however much of this we can analyze with human intelligence, great, which is very little. It's like the tip of the iceberg. And the rest of it is just sort of sitting in a drawer somewhere, sitting on someone's hard drive, not really ever being used. But at the same time, if we were to analyze that data and extract insight from it, that would enable millions, if not hundreds of millions of people's lives to be saved over the course of just a couple of months to a couple of years. And so I see a huge impact of machine learning enabling us to understand that unstructured data, enabling a better healthcare experience. And also at the same time, not only do we have a lot of data and can we save a lot of lives, there's also a shortage of healthcare workers. I mean, even before this entire coronavirus stuff, the World Health Organization estimated that by 2030, we would have 12.9 million fewer healthcare workers than we would need to sustain quality healthcare worldwide. And so now those numbers, I would estimate, are only going up. And that's a problem. We need more people. So machine learning will have a huge impact in that field, but also in the field of education. Because if you think about it, education is meant to prepare the next generation for a future that doesn't even exist. And the way that we currently educate the youth isn't necessarily optimal, because we're teaching them in a way that was never meant for the way that society is structured today. Society has changed more in the past 100 years than it has in the past, 2,000 years before that. And actually, I would say even the past 100,000 years before that, because of exponential innovation. And when you start to see that education has barely changed over the past many hundreds of years, then you start to realize that there's something off there. So we need to apply machine learning to help have sort of more personalized education for students and individuals, to make it so that we can teach people in ways that are more efficient and suited to them, and in ways where they are building that generic problem solving framework, and not just memorizing solutions that already exist.
One last question. I wanted to know what's your best advice to give to young developers, such as the people who are attending this hackathon?
Sure. So really, there are a few things I would say. First of all, I've noticed that whenever you should really be doing whatever it is that you're passionate about. And this might seem like advice that you get from everywhere, and that is, do what it is you're passionate about, or do what it is that you find enjoyable. But I will say that, especially when it comes to the field of technology, this is genuinely very applicable, because I've personally worked, for example, with a lot of people that weren't necessarily passionate about technology, but were still working within the field, and they simply don't excel at really doing much within the field of technology, because when you're not passionate about technology, you're not going to be perseverant, right? You're not going to want to spend time working with that tech and working on code. I mean, even really an analogy that I would give here is that whenever something complex has worked on the first try for me, it's usually been because it wasn't tested hard enough. And so within the field of technology, you're almost never going to have something that works perfectly on the first try. There's always going to be iterations, there's always going to be roadblocks and experience that you're gaining with every new project. So making sure you're perseverant, and a big part of that is being passionate about technology, is really important. But at the same time, one thing that I will also say is, when it comes to technology in specific, making sure that you don't focus on the language and the syntax, but rather the logic, is really, really important. I've seen a lot of people learn how to program, for example, in Python, and once they know the syntax of the Python language, they will think they know how to program. But in my mind, there's a distinction between learning a programming language and learning programming, which is, either the syntax of Python or JavaScript, which is super simple to learn, or you understand the way that you can take a problem and break it down into its individual components to use the syntax or use the tools that a language gives you in order to solve it. So in my mind, it's really about understanding the computational thinking that goes behind programming, and not the programming itself that's important. Writing code is trivial, but what isn't is actually coming up with what code to write. So that's really what I would say would be my main sort of tips to young developers.
All right, so wrapping up this questionnaire, I would like to thank you, Tanmay, for an awesome speech. And I know many of us have been inspired by you and your accomplishments and what you said about machine learning today. We really appreciate it.
Thank you. Glad to be here, and thank you for inviting me. Hope the hackathon goes well.
Thank you.
Thank you.
All right, so